Good
Good morning, sir.
morning, sir. Good morning, everyone. How's your day, class?
We're fine, sir.
Wow naman, napakasigla naman ng mga estudyante ko ngayon. So, are you feeling good right now, class?
Yes, sir.
Are you now ready for a new lesson, a new learning for today?
Yes, sir.
So, to formally start our lesson for today and to start our day right, may I request Mr. Bartolome to please lead us a simple prayer?
Ama na aming Diyos, una po salamat po napakarami. Salamat po medyo nakarating kami magiging sa kanyang bukas at katalinuhan. Una po ang bahala, ma'am. Patawag sana sa ano mo nang kulang o pagtatasal. Una po ang salamat, dalangin mo sa pangalan ni Jesus na aming pagkakalitan.
Amen.
You may now take your seat, class. Again, good morning, class!
Good morning, sir.
Wow, naman napaka-energetic naman ng mga estudyante ko ngayon. So, let's first check your attendance. When I call your name, all you need to say is mabuhay. Is that clear, class?
Yes, sir.
So now let's start with Mr. Arguelles Aaron.
Mabuhay, sir.
Very good. How about Miss Arguelles Vashti?
Mabuhay, sir.
How about Mr. Bartolome Richard?
Mabuhay, sir!
Very good. Everyone is present, so it means let's start now our lesson. Are you now ready, class?
Yes,
Yes,
sir.
sir.
So to start our lesson for today, let's have first a short game named Pictures on the Wall. What am I? What do you call? In this group game, you are going to guess what are the pictures about based also on the riddles that will serve as a clue. You are given a minute to arrange the jumbled letters to complete the given word. Write your answer on a clean sheet of paper, then recite it to the class. Is that clear, class?
Yes, sir.
Are you now ready to play the game Pictures on the Wall? What am I? What do you call?
Yes, sir.
But before that, may I request one of you to please read some rules of our game? Yes, Mr. Aaron?
Rules. Number 1. Do not make unnecessary noise. Number 2. Work as a group. Demerits will be given to the group whose members are not participating. Number 3. Maintain cleanliness on your area.
Thank you, Mr. Aaron. Are all the rules clear for you, class?
Yes,
Yes,
sir.
So now let's start the game. Pictures on the wall. What am I? What do you call? What do you think are those first 4 pictures about? The clue is this. I am a technique used to separate out homogeneous mixtures that contain one or more substances or particles, wherein my process typically involves heating. What am I? What do you call? Who wants to answer? Who wants to answer? Yes, Miss Vashti?
Evaporation, sir.
Very good. Evaporation is correct. Let's give her a clap, class. How about the next picture? What do you think are the 4 pictures about? The clue goes like this. I am a separation method used to separate out pure substance in mixtures comprised of particles, wherein some of which are large enough in size. What am I? What do you call? Who wants to answer? Yes, Mr. Aaron?
Filtration, sir.
Very good. Filtration is correct. Let's give him also a clap. How about those 4 pictures? What do you think are those about? The clue is this. I am a type of mixture which does not have a uniform properties and has 2 or more phases. All components are completely mixed and all particles can be seen under a microscope. What am I? What do you call? Who wants to answer?
Sir,
Yes, Mr. Bartolome?
heterogeneous, sir!
Very good. It's all about heterogeneous mixture. Then how about this next picture? What do you think is the picture about? The clue is this. I am a type of mixture which made up of two or more different substances which are chemically combined. Its composition is uniform throughout the mixture. What am I? What do you call?
Sir,
Yes, Mr. Aaron?
homogeneous mixture, sir.
Very good. It's all about homogeneous mixture. Let's give him a clap again. How about this next picture? What do you think are those four pictures about? The clue is this. I am one of the three primary types of mixture. I am a mixture that has particles ranging from 1 and 1000 nanometers. What am I? What do you call? Who wants to answer? Yes, Miss Vashti?
Colloid, sir.
Let's see if colloids is correct. Are you sure? Because colloids is correct. Let's give her a clap. Whoa, you're very good class. How about these next pictures? What do you think are those four pictures about? The clue is this. I am a type of homogeneous mixture which contains of two or more components, wherein my particles size on which particle is smaller than 1 nanometer. What am I? What do you call? Who wants to answer? Who wants to answer? Yes, Mr. Aaron?
Solution, sir.
Are you sure it's a solution?
Yes, sir.
Let's see if solution is correct because solution is correct. Very good. That four pictures is all about solution. How about the last one? What do you think are those four pictures about? The clue or the riddle goes like this. I am a type of heterogeneous mixture in which some of the particles settle out of the mixture upon standing. What am I? What do you call? Who wants to answer? Yes, Miss Vashti?
Suspension.
Let's see if suspension is correct because suspension is correct. Very good. You all did a great job. Thumbs up to everyone. So all of those pictures class has something to do with our lesson or topic for today. Do you have any idea what is our lesson for today?
None, sir.
Do you have any idea what is our lesson for today? Yes, Mr. Bartolome, what is our lesson for today?
Different types, mixture, and ways of separating mixture, sir.
Very good. Our lessons for today, or our lesson for today is all about different types of mixtures and ways of separating mixtures. But before that, let me read first the objective of our lesson. At the end of the lesson, 90% of the grade 7 students should be able to first determine the particles of a homogeneous and heterogeneous mixture. Next one, classify a mixture based on the particle size, and lastly, enumerate methods of separating mixtures. Is that clear, class?
Yes,
Yes,
sir.
sir.
Now, let's start our discussion by first describe this to illustration. I want you to please see what are the difference between the two illustrations. Are there any differences when it comes to their particle size?
Yes,
Yes.
sir.
There is a difference between the two. Therefore, which do you think among the illustration describes a homogeneous mixture? Yes, Miss Vashti?
Illustration 2, sir.
Let's see if illustration 2 describes a homogeneous mixture because illustration 2 is correct. It describes a homogeneous mixture. How about the illustration that describes a heterogeneous mixture?
Sir.
Yes, Mr. Aaron?
Illustration 1, sir.
Very good. Illustration 1 describes a heterogeneous mixture. Now, what comes into your mind when you hear the word a homogeneous mixture? Anyone from the class? What is your idea when you say homogeneous mixture? Anyone from the class? Yes, Mr. Bartolome?
These are the type of mixture in which component mix are uniformly distributed throughout the mixture, sir.
Very good. When we say a homogeneous mixture, class listen, it is a type of mixture that are uniform throughout the mixture. its particles are distributed uniformly and we can judge a homogeneous mixture by just seeing it. Just like in this illustration, wherein in the illustration 2, you can see that the particles are distributed uniformly. Just like in this illustration, there's a dark light, dark light, dark light, and dark light. Kumbaga, ma-identify mo na yung particles ay na-mix together or mix uniformly. And a good example of this is air. Then how about when it comes to heterogeneous mixture? Anyone from the class have an idea what is a heterogeneous mixture?
Sir,
Any other hand? Yes, Mr. Bartolome, let's see if your idea is correct.
A heterogeneous mixture is a type of mixture in which all components are completely mixed and all particles can be seen under a microscope, sir.
Very good. When we say a heterogeneous mixture, it is a type of mixture wherein its particles are distributed and we can judge its particles based on the mixture. In short, when we say a heterogeneous mixture, class, it is a type of mixture wherein its particles are to be seen or to be identified. Sino na sa inyo ang nakatry na kumain ng halo-halo?
sir,
Isn't it that ma-identify mo kung ano yung ingredients ng isang halo-halo?
Yes,
Yes,
sir.
Would you mind to please give me some ingredients of your halo-halo? Yes, Vashti?
The pasta.
Very good. Dupo or banana. And what else?
Ube, sir.
Very good. Ube. What else?
sir,
Yes?
Beko, sir.
Very good. All your answers are correct because a halo-halo is a good example of a heterogeneous mixture. In short, in this illustration 2 describes a homogeneous mixture. Wherein when we say a homogeneous mixture again, its particles are uniformly mixed throughout the mixtures. There is no clumping or no aggregation about the mixture. And a good example of this is air. On the other hand, illustration 1 describes a heterogeneous mixture wherein there is a large aggregation or clumping in the particles. And a good example of this is when you mix an oil and water. Is there any question, class, about homogeneous and heterogeneous mixture?
None,
None,
sir.
So now, let's continue our lesson by an activity named Sort Me, You Belong With Me. All you need to do is to pick and classify, then sort out the different mixtures based on its particle size. Remember, class, that mixtures can be classified according to their particle size, which are colloids, solutions, and suspensions. You are only given 5 minutes to do the activity. Are you now ready to do the activity, which is Sort Me, You Belong With Me, class?
Yes, sir.
So now let's start. May I call on Mr. Aaron first to please pick 2 mixtures, then classify if it is a solution, suspension, or colloids. And we pick now. Oh, let me help you. Next one, may I call on Mr. Bartolome? Let me see. Very good. And lastly, may I call on Miss Vashti to please pick 2 mixtures and classify it. Let me help you na. Oh. Let's see if your answers are correct. Ako na Very good. Are you sure with your answer, class?
Yes, sir.
Let's see if your answers are correct. But before that, let me fix first our illustration. Ayun, ayos na siya, class. So now, based on our activity a while back, what are the 3 classifications of a mixture based on their particle size? Yes, Mr. Aaron?
Solution, suspension, and colored, sir.
Very good. These are solutions, suspensions, and colloids. Then now, let's discuss one by one these three classifications of mixtures. Let's start with a solution. Based on your activity, what are the examples of a solution? Based on your activity class, what are the examples of a solution? Yes, Mr. Bartolome?
Vinegar on water, orange juice, sir.
Very good. Vinegar on water and orange juice is a good example of a solution. But then, what do you think is a solution?
Sir,
Yes, again, Mr. Bartolome?
solution is a homogeneous mixture of two or more substance and it may exist in any place, sir.
Very good. On the other hand, or as an addition, when we say a solution, it is a homogeneous mixture with tiny particles, and its particles are too small to be filtered out or settled out. And a good example of a solution, again, is a vinegar on water and orange juice. And also, a sugar solution. Because when a sugar and water are mixed, thoroughly mixed into water, it forms a solution. Sugar will no longer be visible in water. When mixed, sugar will not settle at the bottom of the cup. Is that clear, class?
Yes,
Yes,
sir.
So now let's proceed with the next classification of mixtures based on their particle size, which is... But before that, class, let me also add a trivia, because in a solution, there are two substances that are belong, which are the solute and solvent. When we say a solute, it is a substance that is dissolved, while solvent is the dissolving medium. In the example given a while back, sugar and water is mixed. The solute, which is the substance that is dissolved, is the sugar, while the solvent is water. Always niyong tandaan, class, na kapag sinabi nating solute, ito yung natutunaw. At ang solvent ay yung tumutunaw. And remember, class, water is the universal solvent. Is that clear, class?
Yes, sir.
So now let's proceed with the next classification of mixture based on their particle size, which is a colloids. Now, based on your activity, based here on the table, what are the examples of a colloids? Yes, Vashti?
Jam and toothpaste, sir.
Very good. Jam and toothpaste are a good example of a colloids. But then, what is your idea when you hear the word colloids?
Sir,
Yes, Mr. Bartolome?
a colloid is a heterogeneous mixture in which the displaced particles are intermediate in size between those of a solution and a suspension, sir.
Very good. When we say colloids, it is a type of heterogeneous mixture which can be dispersed particles are intermediate in size between those of a solution and a suspension. The particles are spread evenly throughout the dispersion medium, which can be solid, liquid, or gas. Aside from that, class, when we say colloids, its particles are not enough to be settled out or to be filtered out. And just like an example, jam and toothpaste. Is there any question, class, about colloids?
None,
None,
sir.
sir.
Now let's proceed with the last example or the last classification of a mixture based on their size, which is suspension. Based on the activity, what are the examples of a suspensions? Yes, Aaron?
Dust particles on air and flour in water, sir.
Very good. Dust particle on air and flour in water is a good example or are good example of a suspension. But what is your idea when you hear the word a suspension?
Sir,
Yes, Mr. Bartolome?
a suspension is a heterogeneous mixture in which some of particles settle out of mixtures standing, sir.
Very good. When we say a suspension, it is a type of heterogeneous mixture with large particles. Remember, class, the word large particles wherein there are enough to be seen or settled or filtered out of the mixture. An example of this is mud and water. Nasubukan nyo na bang maghalo ng tubig at saka mud o sand?
Yes, sir. Yes, sir.
Therefore, it is a good example of suspension because if the glass is undisturbed for very long, the mixture will separate into its component part. Hindi ba kapag nagmix ka ng sand at tubig, and then iniwan mo yung pinagmixan mong baso, hindi ba magse-settled out yung particles? Yung tubig ay magpapaibabaw at saka yung sand ay nasa ibaba. Is that clear, class?
Yes, sir.
Yes, sir.
Very good. So now, do you have any question, class, about the three classifications of a mixture, which is solutions, suspensions, and colloids?
None, sir.
So now, I want you to please watch carefully a video that will serve as a lesson also and to discuss what are the commonly used methods or ways of separating mixture. All you need to do is watch the video, take down notes of the important details, then afterwards, I will ask you some questions. Is that clear, class?
Yes, sir.
Now, let's watch first the video. Tingnan yung mabuti, class, ha? Look at the important details about the video. So did you understand or learn something about the video, class?
Yes, sir.
So now let's proceed or let's continue our lesson now. So based on the video, what are the different ways of separating mixtures? Based on the video, what are the examples of separating mixtures? Yes, Mr. Bartolome?
Evaporation, filtration, sir.
What else?
Sir.
Yes?
Chromatography and distillation, sir.
And what else again? What are examples of ways of separating mixtures? Yes, Vashti?
Decantation and magnetism, sir.
Very good. All your answers are correct because evaporation, filtration, decantation, magnetism, chromatography, and distillation are commonly used ways of separating mixtures. So now let's discuss it, or let's just discuss the commonly used ways of separating mixture. let's first discuss evaporation. Always remember, class, when we say an evaporation, it is a technique used to drive off the liquid components from the solid components, typically involves heating. Always remember, class, when we say evaporation, it involves heating. Is that clear, class?
Yes, sir.
Then, what about a filtration? When we say a filtration, class, it is a technique which an insoluble solid separated from a liquid. Is that clear, class?
Yes, sir.
And also, on the other hand, when we say decantation, as what is shown here, when we say a decantation, it is commonly used in laboratory, wherein a mixture is settled out, then afterwards, it is settled out through phases, then let that mixture in a certain container undisturbed, and afterwards, the mixture will be separated out. And also, when we say magnetism, from the word magnetism, it uses magnets to separate mixtures. And also, we also have what we so-called distillation. It is commonly used among water station because it is a type of process of separating liquids from a solution based on the difference of boiling point of the substances in the mixture. On other hand, when we say distillation, it is a type of mixture wherein it is used to separate or in order to produce pure water or distilled water. Is that clear, class?
Yes, sir.
Aside from that, we also have chromatography, physical manipulation, and sieving. Is that clear, class?
Yes, sir.
What makes important about separating or ways of separating mixtures is that it helps us to identify the substances in a certain mixture. Like for example, paano na lang kapag may poison na pala yung kinakain mo? You can use those different types of separating mixture to identify kung ano nga ba yung meron sa kinakain mo. Aside from that, factory also use those different ways of separating mixtures to produce pure substances that are essential or necessary to our daily life. Is that clear, class?
Yes, sir.
So all you need to do is to apply all of those ways of separating mixtures in order for us to live in a safe and equal place. Is that clear, class?
Yes, sir.
Now for your next activity, you will work as a group. I will divide you into 3 groups. Present in the class the importance of the different methods based on the video that we've watched and our discussion, wherein how it helped us in our daily lives. You may use poem, post slogan, and jingle to present your creative output. I will only give you 5 minutes to do the activity, after which each group will present their output. Is that clear, class?
Yes, sir.
Your 5 minutes starts now, class. Just tell me, class, if you're done now. Are you now done, class?
Yes,
Yes,
sir.
Then, if everybody is done, may I request one representative to please read their output. Let's start with the group of Aaron. Kindly stand here in front and read your...
I am substance, I am mixture. Matter has 2 broad classes, mixture and substances, each one with differences. Let us start with their appearances. Homogeneous or heterogeneous. Telling a substance from a mixture can be used. When substances are all homogeneous, mixture can be homo or heterogeneous. I am substance, I am mixture. 2 words apart. Just always remember the differences they got to distinguish a substance or a mixture from what is and what is not.
Very good. Let's give them a round of applause. An excellent work for Group 1. How about Group 2? May I request one representative to please read their poem?
Morning, class.
Morning.
Good morning.
Yo, mixture and solution, now I won't lie. Can get a little tricky if you don't try. Mixture can be a separate with your hand, like a spaghetti, fruit salad, and rock and sand. Solution are so different like the ocean combined. The only way to separate is with evaporation, yo. Thank you, sir.
Very good. You really did a great job. Let's also give them a round of applause, class. What an impressive and creative poem that you've created. You've shown how important separating mixtures are. You made mention that it helped us in our daily life. It helped us to identify the substances in a certain mixtures and others. So all we need to do is to be aware, to manipulate, and to use those different ways of separating mixtures wisely. Is that clear, class?
Yes, sir.
So now, to summarize our lesson for today, when we say mixtures, it refers to the physical combination of two or more substances in which identifies of the individual substances are retained. Remember also, as we've discussed earlier, we can classify mixtures based on their size. What are those again? Suspension.
Solution
and colloids.
Very good, class. These are solutions, suspensions, and colloids. Aside from that, we've also discussed the different ways of separating mixtures, which are evaporation, filtration, decantation, magnetism, distillation, chromatography, physical manipulation, and sieving. Is that clear, class?
Yes, sir.
So now, to test if you really understood our lesson, let's have first an exciting game which I think is familiar to you. This game is entitled Fact or Bluff. I have here two flags. I will read the question, then afterwards, identify if the question or the statement is a fact and a bluff. Raise fact or state fact when the statement is true, and bluff if the statement is wrong. Is that clear, class?
Yes, sir.
Are you now ready to play the fact or bluff game?
Yes, sir.
Now let's take a look if you really understood our lesson. Number 1. Who wants to read?
Sir,
Yes, Aaron?
homogeneous a mixture with does not have uniform properties and has two or more phases. All components are completely mixed, and all particles can be seen under a microscope.
Again, a homogeneous mixture which does not have uniform properties and has two or more phases. All components are completely mixed and all particles can be seen under a microscope. By the way, thank you, Mr. Aaron. Do you think it's a fact or a bluff?
Fact!
Who wants to answer? Raise your hand.
Sir.
Yes, Miss Vashti.
Fact!
Let's see if fuck. Number 1 is bluff.
Whoa.
Now let's proceed with number 2.
Sir,
Who wants to read? Yes, Mr. Bartolome.
evaporation is a technique used to separate out homogeneous mixture that contain one or more dissolved salt. My process typically involves heating the mixture until no more liquid remains.
Again, evaporation is a technique used to separate out homogeneous mixture that contain one or more dissolved salt. My process typically involves heating the mixture until no more liquid remain. What do you think? Is it a fact or a bluff?
Fact!
Fact.
Who wants to answer?
Sir.
Yes, Vashti. Let's try it again.
Fact!
Very good. It's fact. Let's give her a clap, naman, class. It's fact. How about this next one? Colloids is a heterogeneous mixture in which some of the particles are settled out of the mixture upon standing. Is it a fact or a bluff?
Sir,
Sir!
Yes, Mr. Aaron.
Bluff, sir!
Let's see if your answer is correct because number 3 is bluff. Very good, Aaron. Let's give him a clap also. How about number 4? The 3 classifications, let's wait, of a mixture based on particle size are solutions, suspensions, and colloids. Do you think number 4 is a fact or a bluff?
Sir!
Sir!
Yes, Mr. Bartolome.
Fact, sir!
Let's see if number 4 is correct because number 4 is a fact. How about number 5?
Sir!
Fog, smog, sprays, jam, and toothpaste are examples of colloids. Is it a fact or a bluff? Which do you
Sir.
think? It's a fact or a bluff?
Sir!
Yes, Miss Vashti?
Bluff!
Yeah, very good. It's bluff. How about number 6? Decantation is a process of separating liquids from solution based on the differences of boiling point of the substances. Is it a fact or a bluff? Do you think it's a fact or a bluff?
Sir!
Bluff, sir!
Let's see if number 6 is correct because decantation is bluff. How about number 7? The particles in a suspension are far larger than those of a solution, so gravity is able to pull them down out of the dispersion medium. Is it a fact or a bluff?
Sir!
Yes, Mr. Aaron.
Fact, sir.
Very good. It's a fact. Now let's see the 3 remaining questions. Flour on water and dust particle in air are examples of suspension. Is it a fact or a bluff?
Sir!
Yes, Mr. Bartolome.
Fact, sir!
Very good. It's fact. How about the next one? Filtration is a technique which an insoluble solid separate from a liquid. Is it a fact or a bluff?
Sir!
Yes, Mr. Aaron.
Fact, sir.
Very good. It's a fact. How about the last one? A solution is a heterogeneous mixture in which some of the particles settle out of the mixture upon standing. I want Miss Vashti to please answer this. Is it a fact or a bluff?
Bluff.
Very good. It's bluff. All your answers are correct.
Good.
Again, let's give all of you a round of applause. You did a great job and you learned something today. Thumbs up for everyone. But now, for your assignment, write an observation about the transport mechanism based on the activity provided below. Write it in a 1/2 crosswise paper. All you need to do is to pour 300 ml of water into each of 2 small bowls. Stir a pinch of salt, label it salt solution and the other one is water. Put slices of raw potato slices will be affected. After 20 minutes, get the slices of potato from each bowl, then compare and analyze. All you need to do is to answer these guide questions. What is the difference between the potato slices in the salt solution with the potato slices in water? How do they compare with the wrinkled fingers? How do things move in and move out of the cell? And lastly, what controls the movement of materials in and out of the cell? Is that clear, class?
Yes, sir.
Last, so if you understand our assignment, answer it properly and keenly because next meeting we will be discussing our next lesson which about the transport mechanisms in cell. Is that clear, class?
Yes, sir.
So do you have any question, class, about our lesson for today? Do you have any question, class, about our lesson for today?
None, sir.
If none, let's call it a day. Goodbye, class, and thank you for listening.
Goodbye,
Goodbye, sir. Thank you, sir.
Ingat kayo.
Ingat ka din, sir.